Okay. So good morning all. This is Venkana. So today we will be starting with the first chapter, that is the quadratic functions. So we are glad that actually we are starting this particular topic on a great auspicious day, that is Nikola Tesla's birthday today, so July 10th. And he is actually one of the very famous scientists, equivalent to Einstein. And his work actually, even in our day-to-day life actually, without having his inventions, we will not be able to live at all. Why? Because if you see in day-to-day life, right, so when you turn on a mixie or a fan or a motor, to drink the water, right, we have to bring the motor, right. Similarly, actually, this motor is a fundamental principle on any of the rotating machines, electrical rotating machines. All these inventions were made by Nikola Tesla. So he was actually one of the very greatest scientists, and I feel that actually he is the world's most intelligent scientist also, right? So we should be actually very much glad as we are starting the chapter 1 on this auspicious day, right? So let us start this particular topic. So this is quadratic functions. So first of all, actually, we will understand what is quadratic functions. So what is a function and what is a quadratic? Why actually this is called as quadratic? Now, so let me start the class. Just give me a minute. Right. Okay. So first, actually, let us try to understand the words. What do you mean by quadratic? By quadratic. Right. So what do we mean by quadratic meaning? In Latin word, quad meaning four. Meaning 4, right? So here actually a quadratic function, usually we call this as ax square plus bx plus c, and this is what actually we call this as f of x is equal to ax square plus bx plus c. This is called as quadratic function, right? But why actually here there is only two, so that is ax, let me rewrite it. So f of x is equal to ax square plus bx plus c. Now in this there is a square term here, but we are calling this as quadratic equation, right, or quadratic function. Why the name quad is? So quad meaning 4, right? So usually when we talk about a square, so a square actually having 4 sides equal. So this one, this one, this one, this one, all are equal, and this is called as a square. Now suppose if the side length is x, and the side length here it is also x, and the area of this will be, so this is just x square, right? So that's why actually the square term implies the area of a square. So that is the reason actually this is called as a quadratic, so involving say square term. And this is the reason we call this as a quadratic function. So that means as it is involving a square term, we are calling this as a quadratic equation. Now actually what do we mean by function? So a function by definition, right? Function. So the meaning of the function is, so the set of input variables having single outputs. Is called a function. That means a set of input variables having one output. Suppose actually if I call this y is equal to f of x. Here y is the output and x is the input. So this is the input and this is the output, and it has to be only one output. The input variable actually can be many variables also, it can be. That is, suppose if I call this z is equal to f of x comma y, and this is also a function. but involving two different input variables with one output variables. The condition is that actually only one output has to be there. Now in this particular case, this is also called a function. Y can be expressed as some function of x and z also. So that's why we call this as the set of input variables having single output. So, but the input variables, any variable can be expressed as a function of other variables here. So that is, if I call this as, see this, so I call z is equal to some function of x comma y, and here y can be expressed as some other function of x comma z, and x can be expressed as some other function of y comma z, and all these things are called as the functions. So this is called as the functions, right? So a function usually a relation between variables. So one output variables, and there can be more than one input variable, but the condition is that only one output has to be there. Now some random functions, if you take it, suppose y is equal to, so x square plus 2 divided by x minus 1. So this is one function. Similarly, x is equal to ax square plus bx, sorry, y is equal to ax square plus bx divided by 2x plus 3. So this is also one more function. And similarly, x can be expressed as y square plus 2. So this is also one more function. Like this, actually we can have infinite number of functions. Now here one variable is derived with another variable, so with some predefined relation. So this is called as a function. Now there are infinite varieties of the functions that we can think of in mathematics, right? But one peculiar function actually we will be always dealing with. That peculiar function is the polynomial. Suppose I take one particular function. Let us say I have actually one particular function, y is equal to, see, ax plus b. So this is actually one function, and this is usually we call this as a linear function. So this is called as a linear function, or this is also called as a straight line. So this is also called as a straight line, a linear function or straight line. Now we take one more. Suppose y is equal to ax square plus bx plus c, and this is called as quadratic function. This is called as a quadratic function, and here x square term is there. That is the reason we call this as a quadratic function. And I can have one more, that is ax cube plus bx square plus cx plus d, and this is a cubic function. Right? And like this, actually we can have infinite number of variables, ax power n plus bx power n minus 1 plus cx power n minus 2 plus dash dash dash. Like this, actually you can express any number of variables actually. So any number of order actually. So this is n minus 1, n minus 2, n can be any value until infinite, right? So this kind of function is called as a polynomial. Right, so this is called as a polynomial, and this polynomial is an important function in mathematics when compared to any other function. So when compared to any other function, meaning I have explained actually other functions, that is, suppose actually x is equal to y square plus 2, this is also a function, and ax square plus bx divided by 2x plus 3, this is also a function, x square plus 2 divided by x minus 1, this is also a function. But when compared to this function and this function, this is actually in a systematic way. Y is equal to ax plus b, x power 1 term is there, and y is equal to ax square plus bx plus c, so x power 2 term and x power 1 term and x power 0 term. Here actually there is nothing, meaning x power 0 term is there. So here actually x power 0 term you can think of, because x power 0 we know that this is going to be 1, so that's why actually we don't need to be explicitly mentioning that particular point, right? And here y is equal to ax cube plus bx square plus cx plus d. So power 3 is there, 2 is there, 1 is there, 0 is there. Similarly, x power n, n minus 1, n minus 2, n minus 3, like that actually until n minus n actually you can have the polynomial. Now all these are actually in a systematic way, actually these are organized. Now we will be dealing most of the times with this kind of polynomial functions only, most of the times in mathematics. There is a specific reason why we are focusing more on this particular type of functions, that is the polynomial function. And the reason behind that is down the line, so when you go to graduation level, you will understand one important factor, that every random function of your own interest, whatever may be the complex function you can think of, that can always be expressed in terms of a polynomial. So that is any random function you can think of, that random function you can always express as a polynomial. That actually you will be learning down the line in graduation. That is why if you understand more on the polynomial function now, then you will be able to understand all the functions, whatever may be the complex function it is. So that theorem actually, so there is one popular theorem, and I feel that actually that is the greatest theorem in mathematics, that is the Maclaurin series. So that is Maclaurin series. And this Maclaurin series actually, you give any random function, so whatever may be the complex function it is, it can always be expressed into a polynomial. That is, f of x can always be expressed as f of 0 plus f dash of 0 into x. Like this actually you can express. So a polynomial actually you are going to get it on the right side for any random function. This is any random function. So that is the reason we will be learning the polynomial functions now, right? In that actually I think you have already learned the straight lines. So the straight lines, so usually y is equal to ax plus b format. So this is called as a straight line. This is called as a straight line. And y is equal to ax square plus bx plus c. This is a quadratic function. This is a quadratic function, right? Now actually, so at least actually until secondary 4, you will be learning only these two functions. And these are actually good enough. Most of the times actually with this actually we will be able to solve all the kind of problems most of the times. That is the reason actually at a secondary 3 and secondary 4 level, you will be focusing only the straight line and the quadratic functions, right? So now actually we will be dealing with the quadratic functions. So in the quadratic function, we have actually 3 different subtopics. So quadratic functions. So in this actually we have 3 different subtopics. One is maxima and minima. And the second one is, right, so graphs of quadratic functions. And the third one is applications of quadratic functions. Right, so these are the 3 different subtopics actually we will be having it in our so methodology, right? So the first part is actually maxima and minima, right? So let us see actually what exactly is present in maxima and minima, right? So first actually let us understand what do we mean by maxima and minima. Suppose I have a function. So any function can always be represented on a graph, right? So any function can always be represented on a graph, right? Now any random function you can think of, but the first function what I am talking about is ax plus b, and this if you try to draw the graph, so this will be on a graphical sheet. So this is being the x-axis, this is being the y-axis, This is always a random straight line like this. So it's a random straight line. So this straight line like this, actually you can have, this is also one kind of straight line, and this is also actually one kind of straight line. Like this, actually you can have any type of straight line, but the equation is always in this particular format. So that is ax plus b, right? Now if you draw the graph of this particular one, so this will always be a straight line. Exactly in the similar manner, if you draw the graph of a quadratic function, that is y is equal to ax square plus bx plus c, if you try to draw the graph of this particular shape, and this will be of this particular format. So this is x-axis and this is y-axis, and then actually, so the shape of the graph may be of this particular format or may be of this particular format. So, but this can be located anywhere on the graph, may be located here, or may be located here, or may be located here. Like this, actually it can be anywhere on the graph, but the shape is a kind of a U shape or a V shape if you try to draw the graph for any quadratic function of this particular format. That is y is equal to ax square plus bx plus c will always be either U shape or an inverted U shape, but can be located anywhere on the graph, right? Exactly in the similar manner, if you take up x is equal to ay square plus by plus c, and this is the kind of function, then actually the graph will be of this particular format. Either it will be like this, or it will be of like this, or maybe located somewhere here, or maybe located here. It doesn't matter wherever it is located, but the shape is either less than symbol or greater than symbol. Like this, actually it will be organized. So any quadratic equation will always be either U or inverted U. If it is y is equal to x square plus bx plus c, the same shape is tilted either to the right side or to the left side if the equation of x is equal to a square plus ay square plus by plus c. Now here a, b, c are constants. A, b, c are constants, and these are constants, and x is a variable, specifically input variable. So this is a input variable, right? Now why we call this as maxima or minima? So maxima and minima, suppose actually if I give a random shape like this, so this is a random shape like this. Now in this case, if you take exactly at the topmost point, and for this entire function y is equal to ax square plus bx plus c, in this entire shape, no value of the function is greater than this highest point. So this actually, if you try to, right, so this is actually, I can call this as, let us say this point is y1, then y1 is the maximum most point on this particular graph. Similarly, if I have one more graph in a different way, that is actually, suppose if the shape is of like this, then actually this is the bottom most point. So exactly this point, if you take it, this is the minimum point. And this is y2, and this is the maximum point. Right? So the quadratic function y is equal to ax square plus bx plus c will always be either U shape or V shape, or either U shape or inverted U shape, and U shape will always have a minimum value, and inverted U shape will always have a maximum value, because every value is actually lesser than this value, even on the right side, even on the left side. So left side and right side, both side, actually you see that the functional value is lesser than the highest point here. And in this particular shape, either to the, so midpoint you take it, so either to the left side or to the right side will always be having a value greater than this bottommost value, and this is called as a minimum value. So this graph is straight away either of this particular format or of this particular format, and if this is the format, you will be having only the maximum value and you cannot find any minimum value, so no minimum value in this particular case. no minimum value in this case, and here no maximum value, right? No maximum value in this particular case, here no minimum value in this case. You will be finding only maximum value here, you will be finding only minimum value in this particular shape. So the first thing actually what we understand is, that is y is equal to x square plus bx plus c will always be either u shape or inverted u shape. If it is u shape, you will be having only minimum value for that particular function. If it is inverted u shape, you will be having only maximum value for that particular function. Now the question is, when you are going to get the u shape, when you are going to get the inverted u shape, is there any specific condition that you can see to identify whether it is u shape or inverted u shape? Now actually I'll take a simple example. So what I do is, I'll just right. Okay, so here we take actually one particular simple case, we take it. So what I do is, so I take one function y is equal to x square plus x plus 1. So this is the simple most function actually that we can think of. And in this simple most function, right, x square plus x plus 1, if you try to draw the graph at different values, let us take actually one particular value. I'll just prepare a table. So this is the x value I consider, and this is the y value I consider, right? And then, so this actually x, if I take it, so x at 0, this value will be 1. So that is 0 square plus 0 plus 1, which is equal to 1. And similarly, if you take x value 1, then the y value is 3. And if I take x value 2, then 2 square is 4, 4 plus 2 is 6, 6 plus 1 is 7. Like this actually we have the different values for 0, 1 and 2. Similarly, I take the negative values also, I take it. That is, if the x value is minus 1, so x value is minus 1, then the corresponding value is minus 1 plus 1 will be 0, and minus 1 whole square is plus 1. Similarly, if I take minus 2, and then minus 2 whole square is plus 4, and minus 2 plus 1 is minus 1. So plus 4 minus 1 is 3, right? And similarly, if I take minus 3, like this actually you can calculate it. So minus 3 whole square is plus 9. So that is 9, and minus 3 plus 1. So this is minus 2. So minus 2 plus 9 is 7. Like this actually you notice the values. Now if I try to draw the graph of this particular shape, right? So this is the x-axis and this is the y-axis. Now at x is equal to 0, the corresponding y value is 1. So at x is equal to 0, the corresponding y value is 1. Similarly, at x is equal to minus 1, so this is at minus 1 you take it, the corresponding y value is also again plus 1 itself. So this is the plus 1, right? So this is the plus 1. And again at x is equal to, so at x is equal to plus 1, the y value is 3. So this is at plus 1, so the y value is 3. Similarly, here also you take it at minus 2 you take it, so the y value is 3, like this. And like this actually, if you try to draw the graph of this particular shape, and here, right, so this value, it will come to like this. Like this actually you are going to get the shape like this. Got it? So like this particular function actually it is drawn like this. Now here you notice that actually the graph is actually U shape. So this is the U shape. And I take one more function, exactly the same function, but with only one value change, that is y is equal to minus x square plus x plus 1. And this is the graph actually I wanted to draw it. Now the corresponding values will be, so if I try to draw the table for this, so I'll just prepare the table here, x value here and y value here. And when x is 0, then the value is 1. And when x is 1 and the corresponding value is 1 plus 1 is 2 and 2 minus 1 is plus 1. So this is again 1. And similarly at x is equal to 2, the corresponding value will be minus 4. Yeah, so corresponding value will be minus 4 plus 2 and plus 1. So that is minus 1, right? Minus 1. Similarly, you take the values for the other values, that is negative values also you consider this. So if you try to draw the graph of this actually, so at x is equal to 0, this is plus 1 like this, and at x is equal to 1, again actually this is also plus 1 like this, and at x is equal to 2, this is a minus 1, so this is actually minus 1 like this. If you try to draw the graph like this, so it will come in this particular fashion. This way actually you are going to get it. See this, the function, if I try to draw the graph for this y is equal to ax square plus bx plus c, and if a is a positive number, greater than 0 meaning positive number, then the shape of the graph will be of this particular format. So this is the shape if a is greater than 0. And similarly, for the same function y is equal to ax square plus bx plus c, and if a is a negative value, then the corresponding value will be in the inverted format. So this is the first value which will be deciding the shape. So if this a value is a positive number, you will always find a minimum value here. So this is the minimum value. And if a is a negative number, you will always find a maximum value. This is the maximum value that you can find it. So based on this, you will be able to find out the maximum value or the minimum value. And also, one more important factor that you can notice is this value for this particular shape, exactly in the middle you are going to get that particular value. So this is the midpoint of the shape on the either side. So this is exactly the middle line. If you draw a middle line like this, even here also you will be finding the same shape, left side and right side, and there in the middle you are going to get either maximum value or the minimum value. Hence actually you can always find out the midpoint for both the values on the x-axis where it is cutting. So that is, let us say, suppose if it is cutting at a random point x1 and it is cutting at a random point x2, and the midpoint will be x3 if you call this. So x3 will always be of x1 plus x2 by 2. So this is the midpoint. And the corresponding y value will be either minimum value or the maximum value depending upon the a value. And y is equal to ax square plus bx plus c. If you call this as y is equal to f of x, then the midpoint x3, that is the value here, it will be the minimum point. Y min will always be equal to f of x3. So this is the y min value. I hope you understood this, right? And similarly, even here also you consider this. So this, let us say if it is at x1 and this value is at x2, then the midpoint x3 will always be x3 is equal to x1 plus x2 by 2. So this is the value, and y max will be definitely f of x3, where f of x is ax square plus bx plus c. So this is how you will be finding out the maximum value or the minimum value for any quadratic function. Got it? So I hope actually you understood this particular concept, and this is the only concept that is present in the quadratic functions with the maximum and minimum as the topic. And if you understand this particular topic clearly, then you will be able to solve each and every problem in this particular book, and with this basic concept, both the example problems and exercise problems of this maxima and minima topic. If you understand this clearly, you will be able to find out. So I'll just summarize the important points. So the first point that you will have to understand is a quadratic equation will always be in the shape of either u or inverted u. A quadratic equation or quadratic function graph will always be either u or inverted u shape, right? And that is right? So this is the quadratic function. And the second point, right, second point that you will have to understand is U shape will always be having minimum point. And the third point, inverted U shape will always be having maximum point. Right? And the fourth point, in the quadratic function, y is equal to ax square plus bx plus c. If a greater than 0, then the shape is always right, a greater than 0, the shape is always the U shape. Similarly, the fifth point is, in the quadratic equation, or actually I'll just rewrite it, right? If a less than 0, then the shape is always inverted. So that is, the a value is less than 0, right? A value is less than 0, then you are going to get inverted U. And if the a value is greater than 0, then it is always a U shape. U shape will always have a minimum value, and inverted U shape will always have a maximum value. And the sixth and important point is, the min or max occurs exactly at the midpoint of the shape. Exactly at the midpoint of the shape, you are going to get either maximum value or the minimum value. So this is the basic concept on this particular topic. So once you understand this particular topic, then in the next class I will be dealing with the problems and the example problems, right? Yeah, that's all. Thank you.